All right, now for the examples. So, example number 1. Say we have the absolute value of 3x minus 4 equals 11. Okay, so if you remember, the thing I need to be looking at to decide if I'm doing 2 or 1 equation is this sign, okay? So this is an equal sign. Remember, equals means 2 equations. Greater than or equal to means 2 equations. Less than or equal to means 1 equation. So this is how I'm going to write the 2 equations. Okay. The first one I write exactly as it is. I just drop the absolute value bars. So you notice it's exactly the same. The second one then, I'm going to write the absolute value part exactly like it is, only with the absolute value bars dropped. And then the number on the other side takes on the opposite sign. Okay? Now all I do is go ahead and solve each of these. So first thing I need to do is add 4 to both sides. And I get 15, and then divide both sides by 3, and I get x equals 5. And over here, I'm going to add 4 to both sides, and that gives me negative 7. And then I divide both sides by 3, and I get negative 7/3. So my answer is x equals negative 7/3 or 5. There's no interval notation here because it's just one number or the other. It's not a range of numbers. Now, let's just check this to be sure, just to see. Okay, so I'm going to, come on back. I'm going to check x equals 5. Okay, so goes back in the original equation. So 3 times 5 minus 4 equals 11. And 3 times 5 is 15 minus 4 equals 11. And 15 minus 4 is 11. You notice I haven't gotten rid of the absolute value bars yet. I have to do everything inside them just like they were parentheses. Now the absolute value of 11 is 11. And 11 equals 11, meaning x equals 5 is a correct answer. Let's check the other one, x equals negative 7/3. Okay, so again, need to put it into the original equation. Oops, not a parenthesis, but okay. So now, when I do this, this is like multiplying fractions, so I can cross cancel the 3's. Then I multiply up the numerators, so that's 1 times 7, negative 7 is 7, and 1 times 1, oh, so this is just negative 7 minus 4 equals 11. The absolute value of negative 11 equals 11. And the absolute value of negative 11 is 11. And so that means that this answer is correct. Okay? Let's do the next example. Let's say we've got 3x minus 4, absolute value, is greater than or equal to, and remember it could just be greater than, 11. Okay, so remember again up here where we saw if it's this now, greater than or equal to, I'm still going to do 2 equations. And again, the first equation that I write is this exactly, okay? I just dropped the absolute value bars. But here's the thing we need to know. When we do our second equation, the absolute value portion is exactly the same as what we did before, but then my sign has to flip, okay? Notice which direction this one's going and which direction this one's going. And then, again, I make this -11. Now, again, this is going to be a range of numbers. So, just like I did up above, I'm going to solve these. So, 3x is greater than or equal to 15 because I added 4 to both sides. Now I divide the 3x by 3 and I get x is greater than or equal to 5. Over here I'm going to add 4, so I get 3x is less than or equal to -7. And then I divide both sides by 3 and I get this. Now, we are going to, these answers, these up here as well, are called, excuse me, this one and this one are called algebraic notation. It's the only way you can get these answers when you do these problems, but that's not what I'm looking for. The two ways I'm looking for answers is either just this, x equals, and then for everything else, I'm looking for a graph and interval notation. Okay, so let's make a graph first. It always works much better for us to make a graph. And so I just do a long line with arrows on both ends, meaning it keeps going in each direction forever. And now I'm going to look at this x is greater than or equal to 5. So I know somewhere in here there's a 5. Don't put in all the numbers or little tick marks, just label the 5. So when we are doing interval notation, if we've got greater than or less than, we are going to use parentheses. If we've got greater than or equal to, or less than or equal to, we are going to use a bracket. That means the bracket means the number is also included. Now know that you do not have to have these in pairs, okay? You can have a bracket and a parenthesis, okay? These, the bracket or the parenthesis goes along with whatever it's next to, not as a pair, okay? And if you learned it this way, if you didn't, then don't worry about this. Just ignore this part. Excuse me. If it's just greater than or less than, it's an open circle. If it's greater than or equal to or less than or equal to, it's a closed circle, which we aren't going to do anymore. We're going to do the parentheses or the brackets. So this is greater than or equal to. So I know I'm going to have a bracket. I just need to figure out which direction that bracket has to go. So let me think of some things that x can be. So can x be 4? Well, is 4 greater than or equal to 5? No, it's not. How about 3? 3 is not greater than or equal to 5. So I know this is not going left. Let's just double check and see about going right. So is 6? Let's try 6. Is 6 greater than or equal to 5? It is. How about 7? Yes. How about 8? So I know that my graph is going to go in this direction. And so my bracket needs to show that it's going that direction. And then all I need to know now, or do now, is draw a very thick line right on the number line and then make an arrow here. Now understand, do not take your graph, this, all the way to the end of the number line, because the graph, the picture of our number, and the number line are two different things, and I need to see them both. This arrow is telling me that this number line is going in that direction forever. And this arrow tells me that the graph is going in that direction forever. Okay? So now let's do the other side. So again, this is going to be, I need to just put this negative 7/3 somewhere, and it doesn't need to be, exactly 7, however many spaces away. I just need to see the endpoints, okay? And they need to be correctly on the correct sides of each other and that kind of thing. This is also going to be a bracket. Now, 7/3 is actually 3 goes into 7 twice, and 1 is left over. So 2 1/3. So 2 1/3. Let's go with 3. Is negative 3 less than or equal to negative 2 1/3? It is. Is negative 4 less than that? It is. If I go the other way, let's take 0. Is 0 less than or equal to any negative number? It is not. So I know that this one is going toward the left, and again, then a big thick line here. Now, be sure, do not label it as a mixed number. Label it as, and let's put this so we can see that better. Label it as the improper fraction that it is. Now, from this graph, I can easily do my interval notation. Interval notation is about taking the endpoints. So the endpoint here is negative infinity. It's going all the way to the left. And the right endpoint here is negative 7/3. Now I need to put something on each side of these to show what's going on. Remember though that brackets mean included, and I cannot ever include infinity, negative or positive, because I don't know where it is. So it can't be included. So the only thing I can put by an infinity is the parenthesis, but I already have a bracket here, so it's just a bracket that goes there too. Now let's do this one. Well, 5 is as far left as I can go in this one, and as far right as I can go is positive infinity. Now I just told you, you can never ever put a bracket next to an infinity because we have no idea where infinity is. So it has to be parenthesis. But when I've got two different things like this, I have to put what's called a math union symbol, and it's not a U, guys. Do not put a tail on it. It's a U symbol, union symbol. And that means, when I look at this, that my x is everything from negative infinity up to and including negative 7/3, and everything from 5, including 5, all the way up to positive infinity. Okay, and this is the graph, and this is interval notation, and that is what I need from you guys, both of those. So I'm going to do some more examples in the next video. We're going to call this one examples number 1, and we'll do the next one as examples number 2. Where'd it go?